even you've brought the scatter plot in now, which makes me happy. So I heard the word trend from Ashley about a minute and a half ago. You can see the trend. It becomes, Anya, a visual trend. Visual trend. And then I heard trend over here from Christy again. And then I heard this relatableness from Emily, very, very good. And then Amy says, if you drew a line, whoa! Where is there a line? Anya, you want to come draw it?
I don't want to come draw it.
You don't want to come draw it? Describe it to me then.
It's a best fit line, so the number of dots above the line need to be the same amount as below the line.
Who told you that?
My chemistry teacher.
So cute. It's adorable. I love that. I'm going to zoom this in a little tiny bit. Was that Higgy Baby? Carol? Higginbotham?
No, Forrest.
Oh, Forrest. I love Forrest. It is. He's a great dude.
We're learning this exact thing in psych.
You are?
Yeah.
Holy, well, that makes me happy.
Andrea.
Well, that was Woodle. Oh, Woodle is
We're
like
right
hard.
online. But
So what I'm hearing is, okay, so how many of you guys have done what's called a best fit line calculation at some point? It sounds like a bunch of you have. A best fit or a least squares regression or a linear regression line. Hands high if you've heard these terms before or if you've used them. That's about half of you. I'm going after the assumption that you never have done it before. And I think we can add, even to those of you who have done it before, I think we can add something to the conversation. And because I'm me, I want to look at the big picture before getting too micromanagerial. What you guys are describing right now is you look at these dots and you said, ooh, I notice a trend. As time moves left to right, what else happens? What? Good, Amy, what's this? Give me context.
It's going up.
What's going on?
Millions of people.
Love it! Millions of people. I think I'm going under 65. Without insurance is also going up. Now, if we can apply this back to what we were just talking about with similar triangles and grade and scale factors, you can see it if you think about it, right? Start at any given reference point. You can start here at 33, although this is arbitrary. If I draw that, I've got a rise and a run, don't I? Got a rise and a run. I rose 2 for a run of 2. Interpret that for me. Interpret that for me.
That one stayed the same, didn't it?
Say that again. Interpret the rise and the run in context. Oh, good. I see what you're saying, Ashley. I'm sorry. I am taking. I'm upshifting to second gear here with you guys, and I apologize for doing this so quickly. I now want context as to what this grade means. We know it rose 2, yeah? And we know it ran 2. But up till this point with grade, we were using the same unit, 2 feet for 2 feet, which would be a 45-degree angle. But now, the x's and the y's have their own context, don't they? So, Anya, please go ahead, interpret.
The rise and the run are the same, so x equals y, so it's the same rate of change so far.
So, interpret it using the phrases millions of people and years since 1990. Go ahead.
So, 2 years after, so 1992, there's 2 more million people, percentage-wise, uninsured.
So how did the rate of, I love that by the way, thank you. So how did the rate of people becoming uninsured change from 1990 to 1992? Please, Christy.
1 million per year.
We gained about 1 million more per year, right? And you guys are all saying the same thing. The rise is 2, the run is 2, that's a 1-to-1. But in context, that means for every year that passed, break it down, similar triangles, break it down. Huh, there's 1991 right there, yes? We picked up a year, we picked up another 1 million uninsured people. We picked up a year, we picked up another 1 million uninsured people. Fair enough? Is that fair? Hopefully that's fair. Can you break it down by half a year? Why not? Half a year? July 1990? 500,000 uninsured people. Another half a year, another 500,000. Another half a year, another 500,000. Another half a year, 500,000. It doesn't matter how you get there, whether you go 2 and 2, or half a 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 half. That's hard to say. Or 1 1 1 1. You get to the same point that Anya just said. In 1992, we have 2 million more uninsured people than we did in 1990. But the kicker is, at what speed did they get there, right? How fast did they get there? Love it. Now let's suppose, if it's okay with you guys, let's then analyze from 1992 to 1994. Is that okay to do this? Is everybody okay with that analysis we just did?
Yeah.
Let's now analyze 92 to 94, if it's okay with you guys. Okay. How many years do we pick up?
Two.
2 more. How many uninsured did we pick up?
2.
Three.
We picked up 3, didn't we? That's 38 million. Started at 35. So now it's a 3, yes? Now it's a 3, yes? Fair so far? Okay. So from 1992 to 1994, we picked up 3 million more uninsured. What's the rate of uninsuredness from 1992 to 1994? I'm trying to be less anecdotal here, Ashley, and more statistical. Can we talk about the rate per year? I'll give you the unit. Per year.
1.5 million.
Say that again. Somebody, I heard a voice.
1.5 million.
Ashley has a vote for 1.5 million per year. You know what I'm going to do? Let me see if the camera can see this. I'm going to go ahead and start writing some of these conclusions next to the graph, if that's okay with you guys, so that we can kind of keep an eye on what we're talking about. So we'll do years. 1990 to 1992. We're going to do the rate. That was the one we just did. That was this one here. That was 1 million per year. I do? Oh, thank
Our
you.
mail
You
too.
do, yeah.
Thank you. I write in all caps mostly because my lowercase is pretty bad. I'm a recovering Catholic school student. My cursive is terrible. So we got 1990 to 1992, about 1 million per year. 1 million per every year. That's an average. I want to start talking about this word right now. After this class is over, in 10 minutes, you will have survived 25% of Math 105. I think 75% of Math 105 should be talked about the word average. Average. I want you guys to walk out of this classroom knowing how to deal with this average and less anecdote and more statistical averaging. Good. Then we did 1992 to 1994, yes? Okay, good. One little squiggly here. And we just decided that was 3 over 2, or 1.5 million per year. It's the same idea of grade, yeah? Same idea of grade. Now, what's kind of cute, and it's kind of how I chose to draw the... When I drew this, it looks like it's a perfectly straight line, doesn't it? But it technically can't be, because the grades change from here to here. This should be kicked up a little bit, should be a little bit steeper. And that's just a function of the fact that I got a fat marker and I'm not drawing super accurately. Fair so far? Shall we continue?
Yes, we shall.
Because we've got 2 different rates right now, don't we? I mean, they're close. 1 million to 1.5 million. And that's close in number, but it's a difference of 500,000 people. That's a lot of people, yeah? That's a lot of people. How many people are in Oregon?
A lot.
A lot. Thank you. I'm just curious as to how many. Yeah, 500,000 is like the population of Wyoming. So if you say these are the same number, you've ignored the population of Wyoming. Which, again, there's not many people there. I love Wyoming, it's beautiful. But you've ignored an entire state's worth of people if we just say they're the same thing. So let's keep going. Let's see if we can get a bigger picture of what's going on. How about 94 to 96?
2.
2 more years, yes?
Yeah.
2 more years have passed. How about the uninsuredness?
1.
Terrible, terrible phrase. 1! What do we got now?
0.5 million.
1994 to 1996, we're at 500,000 per year. So if you kind of pay attention to the rates, as the rates themselves are changing, it started, I put start in quotes because this is just what the CDC gave me and it's not exact. It started at 1 million per year, it ramped up to 1.5 million per year, and then dropped down to 1.5 million per year. Which one is right? Oh, that's the best answer I've heard. I heard from 2 people. They're all correct. It depends on what?
Depends on what the question is.
What question should it be? Hold that average thought, Brittany. Hold that average thought. I like that. Go, Josh. What question are you asking?
Well, are you asking for the average, or are you asking for 1 point to another?
What am I asking? Am I asking for Brittany's average? Because you can see, rather than answer your question directly, Josh, we're going to wrap up with your guys' questions answer here. If we keep going and analyze the next 2 like that, notice they have the same run. They got the run of 2, 2 and 2. But the rise has changed. This rise is 2, and this rise is once again 3, I believe, yes? So if you extend it out from 96 to 98, and then 98 to 2000, the percentage change goes from 1 million per year, And then it goes back, it bumps back up to 1.5 million per year. Now there are at least two ways to look at this. You can say, oh my God, okay, we're okay. Oh my God! That's what the news does. That's what the news does. As soon as something upticks, they freak. Unemployment's up! Or a butterfly flapped its wings in China and caused a tornado in Oklahoma, and now we're back again. The whole butterfly effect, you've heard of that before.
Yeah.
I've heard it's a terrible movie, but it's a wonderful, wonderful idea.
It's a good book.
Is it a good book? Good, I take it. You put Ashton Kutcher in a movie, I don't want to see it. But the idea is, should we hyper-focus on those little tiny changes? And I'm not saying if we should or we shouldn't. I make fun of the news for doing it. But that's because I know they're trying to fill 24-hour news cycles. A better question, as Brittany has just asked, and as Josh has just asked, is maybe we should be looking at what happens over time, over this entire time period, right? So rather than hyper-focusing on every little 2-year period. Anybody question why I did 2-year periods? It was convenient, right? It was super convenient to do that. I had dots on the board. But just because I have all those dots doesn't necessarily mean I should hyper-focus on them. Why not start at my first dot and go to my last one? Now, Anya, was it you that said that Forrest talked about scatter plots?
Kind of.
Kind of, okay. So I just drew a grade triangle. Would he be okay with that? I'm guessing he wouldn't, based on what you told me. He said as many points above and below. Yeah, so he probably wouldn't be okay with this exactly. But what's the rate of change from 92 to 90, or from 92 to 2000? What's the rate of change over that entire period? In other words, ignore what happened in 94, 96, and 98 and focus only on what happened at the beginning and at the end.
8 years.
8 and 8! We went up 8 from 35 to... That's 9, isn't it?
Yeah, 9.
Is that 9? I'm checking. Is that 9? Is that 9? 8, 9-ish. What's a million people?
Right.
What's 2 Wyomings? What's a Wyoming and a Delaware? So 35 to 44, we went 9 million people up. Over how long did it take us to get there?
8 years.
Now, I don't particularly like that, if that's okay with you guys, because this is all per year, per year, per year, per year, per year, per year. That'd be about 1.13 million people per year if we knock it down to 1 year at a time. Is that, check that math, make sure it's right. Check that math to make sure it's right. I think it is. I think it's 1.125.
1.125.
Excellent. Thank you, Brittany. Appreciate the math help. So, pretend you're a responsible news person. Kind of a contradiction in terms. Sorry, news people. You know it's true. What do they read cue cards. It doesn't matter anyway. They're just paid actors. So suppose you're the person making the news cards for them to read. You're the responsible news person's feeder. How would you describe the rate at which the uninsured number changed from 1992 to 2000? Dave?
I would use congressional terms for years in office by a presidency.
Oh, to kind of point blame or point salutation. So that's a very political answer. Depending on what you want to do, if you want to make the president look worse, focus on the years where it's up. If you want to make him look better, focus on the years where it's down. Maybe. That's good. I'm looking for a more statistical, less political answer. That's okay with you. Amy, go ahead.
I would want
Love
to
it.
overlap it with the population.
Good. Oh,
Different colors.
can you, if you don't mind, can you hold that until we analyze which number we should use? Because the population, there's really no question about the population. They do a census so regularly that we can track that, and we've got nice records of that. So that's almost
None
a
of it
gimme.
means focus without that.
Not until, right, but I'm saying we could attack this first and then divide whatever the number we think it should be by that number, get the percentage. Amy's point is an excellent one. We need to know that weighted with the population to see what the percentage is. My point is that's a division, correct? We're going to have the number over the population. I know what this is already, but with almost positive certainty, at least good enough certainty. I'm not sure we should use here. Once we have that, then we've got pretty much a bulletproof number. I love what you're saying. I'm just saying we can worry about that later if it's okay. Excellent. Brittany, go!
Would you say between 1992 and 2000, the amount of Americans under 65 with no health insurance has risen an average of 1.13 million per year?
We could totally say that. You just did, actually. You said it perfectly, by the way. You said it perfectly. Is everybody okay with that? with what she said.
That's the average.
That's, can I take out the word the
Oh,
and
yeah.
replace it with an? That's an
An
average. Now, when you guys, I saw some hands, we're almost out of time. I saw some hands earlier when you guys said you've done best fit lines before in your math classes. How many of you guys did them just like we just did, where you took the first point, took the last point, and connected them with a line? This sounds familiar to a few of you. Five hands-ish, 6 hands-ish. Good, good. That's not always the most statistically correct way, believe it or not. It's a fine way of getting a ballpark, but the problem is, did anybody notice when we did that, we hit exactly 2 points. 1 point's a bit above and 2 points are pretty far below. I want to focus starting Wednesday on this offness right here. Those things are called residuals. Don't memorize that. It's not important to know in your head. But the statisticians pay attention to what are called residuals, because what they want to do is make those residuals, what do you think, as big or as small as possible? They want to make them disappear. The only way to make them disappear, though, is to have what kind of data, Brittany, or everybody? The only way to make those disappear and go away completely is if your data was what?
Empirical.
Say that again?
Empirical?
Maybe empirical. I was looking for a more mathematical answer.
Like linear?
Perfectly linear. Perfectly. It would have to go over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1. Stare, stare, stare. That wouldn't have any residuals, because you'd be like, you ever seen The Fugitive? Movie The Fugitive? Why is Harrison Ford running from the one-armed man?
Because he's Harrison.
I didn't shoot my wife.
That's a brilliant Harrison Ford, because the data he was being chased about was too perfect. When the data comes at you that perfect, that was such a freakishly good impersonation of him. When the data comes at you too perfectly, you begin to question the authenticity of it. If I saw data that said it rises I've only seen data like that a couple times in my life, and it's always very comical. Like, for example, I think I've told this to you guys, if you track the population of the US and the number of Methodist ministers in the US, and the number of cases of Cuban rum imported into the US over that same time period, it's perfect! For every, minister, there's 30 cases of rum. It's almost perfect. And I laugh. We laugh because it's cute. But you don't see data that perfect. You see data that's ish, linear. You're going to use this term too, the word average, which is tied into the word ish, or the suffix ish. That is not a perfect line. It's ish a line, which means it has residuals, which means our job is to control the residuals. That's what we'll start on Wednesday. Cool? You're going to send me an email writing me about your TI-89. I'm going to have a custom booklet made for you. Bring your TIs if you have them on Wednesday. They're going to come in handy for us, for sure. They're going to do a lot of fun mathematics for us. And I say fun, I mean annoying mathematics you don't want to do.